Hi guys, welcome back to another video. Today we have a very crazy problem related to the Canada Mathematical Olympiad. Let's check out what we have. So we have, let AB be any real number such that AB plus square root of AB plus 1 plus square root of A square plus B times square root of B square plus A equals to 0. Then we need to find the value of A times square root of B square plus A plus B times square root of A square plus B. So before start the session, please subscribe, like, share and comment. Let me write this. We have AB plus square root of AB plus 1 plus square root of A square plus B plus times B square plus A equals to 0. So our first step is that to do squaring to the both sides of the equation. Before we do this, we need to rearrange the terms of this equation. So let's do this. What we are going to do, we want to shift this term square root of AB plus 1 to the right side. So first we write this one, square root of A square plus B times B square plus A equals to minus of square root of AB plus 1. As the term switches from left to right, so before we have plus sign, so now we have negative. Our next step is to squaring the equation, squaring to the both sides of the equation. Okay, so what we are getting, we get AB plus square root of A square plus B times square root of B square plus A whole square equal to minus of square root of AB plus 1 whole square, and this will become AB plus 1. It's very easy. So now we are going to compute this whole square term. What we are getting? We are getting A square B square plus square root of A square plus B whole square into B square square root of B square plus A whole square plus 2 into AB times square root of A square plus B square root of B square plus A is equal to AB plus A times B plus 1. So let's simplify this. A square B square plus A square plus B times B square plus A plus 2 times AB times square root of A square plus B times B square plus A, which is equals to AB plus 1. Now we are going to simplify this one. And what we are getting? We are getting A square B square plus A square times B square plus A cube. A square times A will be A cube plus B into B square means B cube plus AB, and the term remain as it is, 2 times AB times A square plus B times B square plus A, which is equal to AB plus 1. Okay, so now we have AB to the both side of the equation. We can cancel out. After cancelling, we are going to rearrange the term. Okay, how do we do that? Please check this. A square B square plus A cube plus we are taking another A square B square with B cube plus 2 times AB square root of A square plus B times B square plus A is equal to 1. So we can write this expression as A into square root of B square plus A whole square. Okay, actually we are taking common A square, and then we are writing that squaring terms. Similarly we can write, okay, similarly we can write b square into, b into square root of a square plus b whole square. Okay, sorry. Okay, right, plus 2 times ab square root of a square plus b square root of b square plus a equal to 1. Now you can see why we are rearranging the term, because now we can write a times square root of b square plus a plus b times square root of a square plus b whole square. You can see that, which is equal to 1. So from here we can say that a times square root of b square plus a plus b times square root of a square plus b is equal to plus minus 1. We are, because we are square root, we are doing the square root of to the both side of the equation, so it will become this, and then the square root of 1 is plus minus 1. But you think that the problem is solved? No. Now we need to identify that which one is correct. Okay, so in order to do so, first we need to understand what is the relation between a and b. Okay, so from the initial equation, we can write ab is equal to minus square root of ab plus 1 minus square root of a square plus b times square root of b square plus b. Okay, please check the initial equation. This one from here we can write. Okay, so you can see from here we can say that this will always less than 0, which implies ab less than 0. That means a and b will have opposite sign. What does that mean? That means that if a is positive, then b will be negative. Okay, so we are taking, without loss of generality, taking a will be positive, means a greater than 0, greater than b, that means b is negative. So now a times square root of b square plus a plus b times square root of a square plus b, which is equals to a times square root of b square plus a plus b minus b into a minus square root of a square plus b. We can write that, because if you multiply this one, actually what we are doing, we are adding one ab and you are subtracting another a. Okay, then yeah, then what is the benefit of this? You can see. So now b square plus a is always a positive and always greater than b square. Okay, and we know that b is negative, so that means these terms always greater than 0. Similarly, we have a square always greater than a square plus b, since we have b less than 0 and a is positive. So that means this is also, this entire bracket term also greater than 0. This bracket term is greater than 0. Now we say that, now you see the entire expression, we have minus b. Minus b means positive because b is less than 0. So that means this entire term is greater than 0, which implies a square root of b square plus a plus b times square root of a square plus b always greater than 0. So we can say that a times square root of b square plus a plus b times square root of a square plus b equals to 1 from here. So from here we can say that. So we have proved it. Thank you. God bless you all.